Welcome back to finish section 7.1. I wanted to talk about some of these example problems that we're looking at that talk about more about these real world sort of applications. We're going to graph some of these. We're going to kind of evaluate them and find out, I guess, answer a few questions about each different situation. All right, so let's look at example 1. A certain car depreciates about 15% each year. So just key phrasing here, depreciates is usually a word that references some kind of decay. Something's going down in value. So this is my hint that whatever we're doing here is probably talking about exponential decay. So we're going to write a function to model the depreciation in value for a car valued at $20,000 originally. So what we know is this function is going to be exponential decay since it's depreciation. Now that means our function will look somewhat of this form, y equals a 1 minus r to the x power. All right, so first my a value is my starting amount, which my starting amount for my car was $20,000. So this equation, y equals $20,000 will be my a value. 1 minus r. R is my rate, and my rate, typically given as a percent, is here. However, we're not going to put 15 in the equation. We're going to put 0.15. That's the decimal version of 15%, so we're going to be using 0.15. And then to the x power, because we're not trying to evaluate at any certain number of years. X is our variable that typically represents time. In this case, it'd be referencing years. You can see your x-axis down here would be 1 for 1 year, 2 for 2 years, 3 for 3 years, etc., etc. So if we want to graph this function, we're going to need a calculator. Now, whether you have a graphing calculator or not, it's not extremely necessary to have a graphing one, but it is necessary to have a calculator in general. So if you have a calculator in general, it's not a graphing one. What you can do is just type in your function, 20,000, 1 minus 0.15, and then raise it to different times and just get those values and write them down. So we can plug in 1 for 1 year and get that value and write it down, and we'll put that on the graph. We could go back and change this to 2 years. I'm not sure how I could do that on the computer, but you could just retype it out and change 1 as the exponent to 2, and change it to 3 and 4, and then on and on, to collect data points. But if you have a graphing calculator, what you could do instead is, if you go to your y equals and type in the function there, again, our variable is x, we're not plugging in any number in this case. You can hit second and the graph button to take you to the table, and this table will show you exactly everything you would have found by doing it by hand or doing it one at a time. So you can see 0 years, the cars were $20,000. After 1 year, it's worth $17,000. After 2 years, it's worth $14,450. And all the table's already created. All data points are already evaluated. You don't have to do any more work. The calculator kind of did everything. All right, so I'm going to use them to help me graph. If I can remember correctly, I'll try to do this on this graph. We'll see if I do a good job or not. 20,000. 1 year, I think it was 17,000. Then about a little less than 15. About 12, I think. I'm trying to remember all of them. Then I think it goes just below. It goes a little bit above 10,000. Then it goes a little bit below 10,000. And it just keeps going down. And you can see the exact data points if you want to make a perfect curve, but it would be something kind of along those lines. All right, now suppose the car was worth $20,000 in 2005. What is the first year that the value of this car will be worth less than half of that value? So half of that value would be 10,000. So if you look at the graph, you can see where it would be worth $10,000. And the first year that we notice it drops below that is year 5. Now technically it does look like it drops below a little bit before it reaches that mark, but in terms of, I guess, answering this question, it's looking for like a whole, what year would I get to where I know it's less than $10,000? Like what whole number year? And the correct answer there would be 5. The 5th year is when it'd be, the first year it would be below 10,000. So we're going to say 5 years, but now we're not going to say 5 years as our final answer because it's 2005 when it started. 5 years after that would be 2010. So that'd be the correct answer to this question. It is 5 years, but it's 5 years after 2005. All right. This next one, we'll just kind of do the second one, and we'll end it there just to save a little bit of time. Because these all are pretty much the same. You kind of just continue to use your graphing calculator to get the values and graph them and write a function. So we're going to write a function here for this situation. Some real estate agents estimate that the value of a house could increase about 4% each year. All right, so if the house is increasing, that means growth. Its value is going up, this would be exponential growth. So if we're going to write a function, our function is going to be in the model y equals a and then 1 plus r to the x power. So a, again, is typically our starting amount. Our house is being valued at $100,000, so we're going to start with $100,000. And then we're going to add our rate. Now our rate, typically given as a percent, is 4%, but as a decimal is 0.04. So we're going to plug in 0.04 and then go to the x power. All right, again, we're not plugging in anything in for x right now. We're just writing the function out in general. But we can plug things in for x when we want to try and graph it, when we want to find specific data points to put on the graph. So for this graph, I know that, again, you can pull up the calculator. You can pull up the calculator and type in this function, and we'll see that we know 0's 100,000. Oh, I just got rid of everything, but we'll put it back up there. You can type in the function y equals, clear out the old one, 100,000. Then we can type in 1 plus 0.04 to the x power, second, and graph. So you get all the data values. You can go back to your function and graph those data values. So y equals 100,000, 1 plus 0.04 to the x. 100,000, it was 104, a little over 108, about 112. This is not perfect by any means, but you could just use the data points. Again, the calculator kind of had everything already out. Now, what year will it reach at least 130,000? So I'm going to go back to the graphing calculator just to emphasize that because it's a little bit better than looking at my graph. But 130,000, you'll notice 6th year it was 126,000, but on the 7th year it was 131. So on the 7th year it surpassed 130,000. So what year is that? We're not going to say year 7 because it's starting in 2005. 7 years past 2005 would be 2012. That'll be the first year that this house will be worth over 130,000. All right. For the sake of saving some time, the rest of these questions are all very similar. They ask you for the function. Remember about the starting amount. Remember about the rate and it being a percent to a decimal. And then you're pretty much good to go. If you have any questions, just come ask me in class. Have a good one. Bye-bye.